Hello and welcome to all of IGCSE Maths Edexcel Mathematics A, although there's lots of content in here for Mathematics B as well. And I go through those key top 10 topics that you really need to know very well to succeed in your exams. So number one is surds, and probably no surprise to you at all that surds does make my top 10 list. I'll go through a few questions here, really make sure your surd skills are up to scratch. Okay, and on to the surds part of the video. Always an important topic on all IGCSE Maths courses. So the first question is a typical show that question. So we need to show that root 45 plus root 20 is equal to 5 root 5. And it's a good skill to be able to do these kind of questions because these come up both at A level and IB as well. So the way we approach this is we take the left-hand side, so LHS, which is equal to root 45 plus root 20. And we're going to do a little bit of jiggery-pokery. We're going to manipulate it here and we'll make it look like 5 root 5 at the end. Now, to simplify your surds, we need to think which square numbers go into 45 and 20. Now, to remind you of those square numbers, remember a square number is just timesing it by itself. So 1 times 1 is 1, so that's a square number. 2 times 2 is equal to 4. That's a square number. 3 times 3 equal to 9. That's a square number. And we'll do 4 times 4 is 16. It's also a square number. Now again, if it helps you, you can always write these out at the side. That's absolutely fine. And then you've got those numbers to refer to. So the first thing, we look at the 45. Which of these numbers in the boxes on the right go into 45? Well, looking through, again, it can't be 4 or 16. 1, again, everything goes into 1. That doesn't really help us. So 9 becomes the obvious candidate. So what do I multiply 9 by to get 45? Well, I multiply by 5. So I can rewrite this surd here as the square root of 9 times 5. I can do a very similar process with 20 as well. Which of these numbers goes into 20? Well, it's an even number, so it has to be one of 4 or 16. 16 doesn't fit in, but 4 certainly does. And then we do the same kind of thinking here, which is what do we multiply 4 by to get to 20? Well, that's also going to be 5 as well. So we're trying to break these numbers down where one of these numbers is a square number. Now, one thing you can do with surds is you can split them. So what I mean by that is we can write this now as square root of 9 times square root of 5 plus the square root of 4 times the square root of 5. And we already know we're on the right track because notice in the answer here is a root 5. We're getting root 5s here. Everything kind of fitting together at this point. Now, we now need to know our square roots, our exact square roots. So the square root of 9, if we're trying to work this out, something times something gives us 9. What will that something be? Well, it's going to be 3. So the square root of 9 is 3. So we write 3 root 5. Remember, with algebra, you don't have to write the multiplication symbol. So 3 root 5 means the same as 3 times root 5. And likewise with this one here, the square root of 4. So let's think of two numbers that multiply to give me 4, and both are the same. That's going to be 2. So the square root of 4 is 2, giving me 2 root 5. And this is where some students get a little bit confused. They think, oh, what do I do from here? Well, think of this question like this. If it was 3a plus 2a, that's equal to 5a. 3 apples plus 2 apples is 5 apples. This now works in exactly the same way. So 3 root 5 plus 2 root 5, that then gives you 5 root 5. 3a plus 2a is 5a. 3 root 5 plus 2 lots of root 5 is 5 root 5. And notice we've now got the right-hand side which we're looking for. So we can now say the left-hand side now looks like the right-hand side and gives us all 2 marks. On to part B, and now we need to express this 2 over root 3 minus 1 in this form p plus root q. Now notice on Edexcel specifically, they don't give you this phrase which I talk a lot about on Cambridge, which is rationalise the denominator. So one of the differences between the course here is you need to remember that if you've got a surd as a fraction in some way, you're going to have to do this process. Now, what do I mean by rationalise the denominator? Well, we want to get a whole number in the bottom of our fraction. So let's go through these steps. It's a very important skill. What we do is we multiply by its conjugate. And you're probably thinking, what kind of crazy words is Ginger Mathematician mentioning here? Well, what I mean by this is we multiply by the so-called positive version of it. So what I mean by this is we're going to multiply top and bottom by root 3 plus 1. Notice if you multiply by something the same top and bottom, like say I multiply something by 2 over 2, you're just multiplying by 1. You're not actually changing what the thing is. Now, the reason we want to do that, and I'll show you this now, it's handy to put the brackets in, is we're now going to do some expansion of brackets. So if I'm looking at the bottom here, and I'll write this separately, what we're going to do is multiply root 3 minus 1 by root 3 plus 1. And by following this conjugate idea, we will get a whole number at the bottom, which is what we want. Now, to remind you how we do this, again, different teachers have different way of teaching this. You might have heard of FOIL. You might have heard of multiply everything by everything. Again, there's lots of ways of doing this. I'm going to use the double eyebrow because it's fun. So root 3 times root 3 is our first step here, which is equal to 3. Root 3 times plus 1 is equal to plus root 3. Minus 1 times root 3 is minus root 3. And minus 1 times plus 1, please be careful here, is equal to minus 1. Now, if I went through that too quickly, again, rewind the video and go through those steps slowly. The reason I call this the double eyebrow is notice you've got kind of eyebrows top and bottom. Also the double hook or double claw, you might have heard that as well. Now, the reason we multiplied these specific things together is if we've got 1 root 3 and minus a root 3, we have nothing. It's like a minus a. So these two things cancel, which is the whole point of this process. And then we get 3 minus 1. Well, that's just equal to 2. So we can just replace the whole denominator now just with the number of 2. Now, we're going to be smart about how we approach this question because we've got 2 times this. Now, many people will just expand the bracket straight away. But there's no need to actually do this in this case. We could, but an easier way of simplifying this, notice we have a 2 on the top and a 2 on the bottom. Everything's involved multiplication, therefore we are allowed to cancel here, giving us then just root 3 plus 1. Now notice the question wants us to write it the other way round. It's very, very sneaky, so be careful. So they want the integer first, the whole number first, 1. And then the surd afterwards, so root 3. This now allows us to identify that p is equal to 1 and then q is equal to 3. One of the biggest mistakes that could be made is you get those the wrong way round, you may lose a mark. It depends on the mark scheme involved. So this is a process called rationalising the denominator. You need to know that if you get a fraction with a surd, this process is probably going to happen at some point. Okay, and on to a very sort of unusual style question, because we are going to talk about quadratics later in the video, and it wants us to write it in this very strange form. Now, this is called completing the square form, which, again, we talk about in other parts of the video, and many videos on my channel. I've actually done a whole video just on this topic. If you type in Ginger Mathematician completing the square, you will find it. Now, where it includes surds, notice the coefficient, the number in front of the x, is a surd. So this is where the surd bit links in. And at the higher levels of the IGCSE Edexcel course, you need to be able to combine one or more topics together and have that fluency between them. And this is a question just like that. Now, in order to complete the square, the standard process, what we do here is we set up a single bracket, we put an x at the front, and we put half of 6 root 2. Well, half of 6 is 3, so we're going to write 3 root 2 all squared. So that's the way we set out this part. Now let's just multiply this out as if there was nothing else to do here. So we're just multiplying out this double bracket. Again, we're using FOIL again, that first outside, inside, last, or the double claw, or the double hook, whichever you prefer. We'll go through it sensibly. So we've got x times x, that's equal to x squared. And we've got x times 3 root 2, that's equal to 3 root 2x. Then we have 3 root 2 times x, that's 3 root 2x. And then finally, we've got 3 root 2 times 3 root 2. Now I'm just going to write that as 3 root 2 all squared, because anything times itself is just squaring it. Now if we collect up the like terms here, the x squared stays by itself. 3 root 2x plus 3 root 2x is plus 6 root 2x, which is good because that's exactly what we have here. So that should be the case. Now let's focus on this 3 root 2 all squared. So if we do this, so 3 root 2 times 3 root 2, and students often find this quite tricky to do. Focus on the numbers separately to the surds. So what I mean by that is we do 3 times 3 first, which is equal to 9. Then we do root 2 times root 2, that's equal to 2. And then we do 9 times 2, which is equal to 18. So actually, this part here just becomes plus 18. So if we multiply it out normally, we get almost what we want here. Almost. Apart from, instead of a minus 1, we get a plus 18. So what I think to myself now is, if I'm at 18, imagine you've got a number line here. Here's 18. And I want to get to minus 1, because that's what's in my question. What do I have to do to 18 to get to minus 1? Well, I need to subtract 19. Notice those negative number rules are very, very important. So this is how I work out what number comes in afterwards. And if you get really stuck in the exam and really not sure where that's come from, you can always multiply the brackets out, collect everything together, and then you'll get the answer that you're looking for. So that's our final answer. We're going to write down x plus 3 root 2 all squared minus 19. What I would do personally here, I'd actually write down specifically a is equal to 3 root 2 and then b is equal to minus 19. You just don't want to lose a mark just for the lack of clarity of your answer at the end. Okay, so you can check through the working there. You can see where you pick up your method marks and your accuracy marks as well. Okay, on to our next question here. So slightly different style. I want to see lots of different styles in this very big video. So show that root 20 plus root 80 over root 3 can be expressed in the form root a, where a is an integer. Remember, integer, that's just a very complicated word for a whole number. And we need to show our working clearly here. So my temptation at the start here is just to simplify the numerator. So we take the numerator here, so the top of the fraction, that's equal to root 20 plus root 80. And we're going to do a very similar process to what we did in the very first question. If I write down my square numbers, so 5 times 5, 25, 6 times 6, 36, 7 times 7, 49. I want to see which of these numbers fits into 20 and fits into 80. Well, we actually did this one already, root 20. Remember, we worked this out as the root of 4 times 5. You can also do it the other way around as well. 80, however, we haven't seen so far, but notice actually that we've got here, and this is a harder one to spot, this is 16 times 5. Now, if you miss that simplification, you can always simplify it in 2 steps rather than 1. That will still get you to the same answer. Again, you can check that 16 times 5 is equal to 80. And then we separate this out. So we have root 4 times root 5 plus root 16 times root 5. And we already worked this one out. So this became 2 root 5. And we do this in the same way. So you look at 16, What two numbers multiply to give me 16, which are the same? Well, that's equal to 4. So the square root of 16 is equal to 4. So we get 4 root 5. And again, we can add these two things together. It's like 2a plus 4a is 6a. 2 root 5 plus 4 root 5 is 6 root 5. So we can change this entire numerator here to just 6 root 5. So I'm going to change this now to 6 root 5 over root 3. And now again, we've got a fraction and a third, so we're using the other process that we've already looked at here, which is rationalizing the denominator. Now the way we do this is a bit more straightforward to what we looked at before. All I need to do here is multiply by root 3, top and bottom. Now you're thinking, why root 3? Why isn't there something else there? Well, let's just work it out. So if we do the bottom here, root 3 times root 3, that's just going to be equal to 3. Okay, you can think of this, if you find that confusing, root 3 times root 3, that's equal to root 9, and root 9 is equal to 3. Again, you can do this in a couple of different ways. Here, again, we've actually just got 1 root 3. If you want to have the integer there to help you, 1 times 6 is 6. Root 5 times root 3 is equal to root 15. Okay, so we've not quite got to an integer yet, but we're certainly getting close. First of all, we have a cancellation here. So we have 6 divided by 3. Well, that's going to be equal to 2. Or another way of thinking of it is 3's into 3 go 1. 3's go into 6 twice. So we get 2 root 15. And you think, surely that must be the right answer at this point. Not quite, because we want this as one single square root. So we're going to work backwards to what we did earlier. 2 is the same as the square root of 4. And then the square root of 4 times the square root of 15, that's equal to the square root of 60. So our answer here is just going to be a is equal to 60. And you've seen this in previous questions. I do like setting out very clearly, this is what a is, this is what b is, and so on. Okay, so you can check the mark scheme here, so you can have a look through and just see all the different steps that we have gone through. If you've liked this video, then please do put a like on the video. It goes a long way to saying to the community out there, this is the kind of video you want. Me doing these all of IGCSE videos, all of A-level videos. So you've really got something you can sit down with and really revise from very effectively. And number 2 is percentages. So knowing your compound interest, working with that 3-step procedure to work with percentage change and reverse percentage change. I go through some fairly tricky questions on this topic. Okay, and on to our section on percentages. Again, a very, very key topic, and it can be quite an easy question like we're going to start with here, but also more difficult questions towards the end. So Hiran here has invested 20,000 rupees in an account for 3 years. Again, underlining that key information is important here, at 1.5% per year compound interest. So we've got that key phrase, compound interest, and we want to find out the total amount of money after those 3 years. Again, nice to also know how they want you to round here, in this case to the nearest rupee. Now, I really do suggest that students learn this formula off by half, compound interest, because it's not on the formula sheet, but if you know this formula, you can gain a whopping 3 marks by just putting the right numbers in the right place. So the formula is, to work out the total, we start with the original, sometimes known as the principal, multiplied by the very mysterious name of the multiplier, to the power of the number of years. So this needs to be a formula that's imprinted in your mind. Again, if you go onto my YouTube channel, you'll see my IGCSE cheat sheet, and this formula is there. Now, what's which? So in this case, we've got the original. So that's our 20,000 rupees that we start with. Now comes the most trickiest part with the multiplier. So what do I mean by this? Well, we have 1.5% per year increase. Yeah, we're making money on our money, so to speak. So to work out our multiplier, we take the original, 100%, we add on 1.5%, and if we do that, you can use a calculator, of course, we get 101.5%, but we want to turn this into a multiplier, so we take this number and divide by 100 to give us the multiplier. So that will, you can think of it as moving the decimal point twice, if that helps. That gives you 1.015. So this is this crucial number that we're going to see a lot in this part of the video. So our multiplier is 1.015, and then to the number of years, well, we're told that in the question. This is why we underline key expressions, which is 3. So by putting these right numbers into our formula, we can then just press the buttons on our calculator. So 20,000, got a standard Casio calculator here, multiplied by 1.015. And now we like to use this x with a little square on it. That helps us then to put to the power of 3. Press the equals button, it will do its thing, and that gives us 20,913.567 ... And we want this to the nearest rupee, so the nearest whole number. So because after the decimal point we have a 5, we're going to round this upwards, and that's going to give us 20,940. So make sure you're rounding carefully. You don't want to miss out on 1 mark just because of a rounding error. And this comes up every year with IGCSE students. These rounding errors, try and avoid them where you can. So you can see the mark scheme here, and there's our final answer of 20,914. Right, on to our next question. Often quite a lot of text in these questions, so it's important to read it through carefully. So Gopal is paid 20,000 rupees each month. Jamuna is paid 19,200 rupees each month. Gopal and Jamuna are both given an increase in their monthly pay. So they're both going upwards. After the increase, they're both paid the same amount each month. Okay, that's important. Gopal was given an increase of 8%. Work out the percentage increase, that's important, that Jamuna was given. So there's lots of things to think about in this particular question. So what I'm going to focus on here is that Gopal was given an increase of 8%. So let's work out how much he had after his increase. So Gopal new total. And what we want to do here is increase his salary 20,000 by 8%. Now, there's a few ways you can do this. I'm going to stick to my multiplier method. So we're increasing by 8%, so 100% plus 8%. That is equal to 108%. And then to turn it into a multiplier, we divide that by 100. Similar process to what we've done here. That gives us 1.08. So this is the way I like to approach these questions. Again, work out the multiplier, and all we need to do to work out his new amount he gets each month is take 20,000 and multiply by 1.08. Again, you could work out 8% manually and add it on. That is also perfectly fine. So if we pop that into our calculator, we then get 21,600. Now let's focus on Jamuna. So we're going to approach this in a very similar way. So she starts with 19,200. We know that she wants to end up at the same as Gopal. So we want 21,600 at the end. And then we need to multiply it by something. So what's that increase to give her 21,600? So let's just give this a letter. Let's call it y in this case. And let's work out what y is. This is just an equation. So the opposite of multiplying by 19,200 is to divide by 19,200 on both sides. This cancels, leaving us with just y, and then we need to divide 21,600 by 19,200. This won't give us the answer immediately, but certainly will help us on our way. So if we pop this into the calculator, any calculator will be fine here, we then get 1.125. So what we do here is kind of the opposite of what we did at the top here. So we have the multiplier and we want to work out the increase. So I take my 1.125, I'm working backwards here. I'm going to times this now by 100. That gives us then 112 12.5%. So the increase, what have we added to 100 to get to 112.5% is 12.5%. So that is our final answer for the 4 marks. Notice being comfortable with these multipliers, working backwards and forwards, helps you with a lot of different questions on this IGCSE course. And again, you can see the answer here, so 12.5%, and they've worked out in a slightly different way or slightly different approach to what I've taken. Right, on to our next question here, so question 12. A company makes cars. In 2016, the company made 350 cars. In the first 6 months of 2017, so the first 6 months, the company made 25 cars per month. In the last 6 months of 2017, the company made 45 cars each month. And again, we want this percentage increase in the number of cars the company made from 2016 to 2017. So our first task here is to work out how many cars produced in 2017. So if we work this out here, well, we have 6 months of 25 cars, so we're going to do 25 times 6, and then we're going to add on the last 6 months, so that's going to be 45 times 6. And again, we use our calculator here to work this out, so 25 times 6, adding on 45 times 6, so that's going to give us 420, like so. And what we want to do is work out the percentage increase between 2016, so 350, and 2017, which is 420. So there's a useful formula to know here. So percentage change, again, worth learning off by heart here, which is the difference between the two things in the boxes here, divided by the original, that's important to remember, and then we times by 100. Again, worth learning this formula off by heart. So the difference between them, so between 420 and 350, that's going to be 70. And then we divide by the original, so that's 350, and then times by 100. Now again, you could do some cancellation here, or just use your calculator directly, that's absolutely fine. Again, always take the lazy approach if you can, and if we work this out in either way, we'll then get our answer of 20%. So for 4 marks, I think that's quite generous to give you 4 marks for this kind of question. But again, there's a little bit of reading of the question that maybe some students won't get all the marks on this particular style of question. Now on to part B. It's a nice little question here. Again, this question 12, so it's a bit harder through the paper. So the company's income in 2017 was $500,000 more than company's income in 2016. The company's income in 2017 was also 8% more than the company's income in 2016. Work out the company's income in 2016. So whenever I get a question like this where I don't have anything to represent the company's income in 2016, let's give it a letter. So I'm going to call it X in this case. So X is the company's income, nice and clear for the examiner, in 2016. Now there's 2 ways of expressing company's income in 2017 by using the 2 statements here. In 2017, it's either whatever X is, and then we add on $500,000, big company, or we can think of it as increasing X by 8%. Now remember, with the multipliers, if we take 100%, add on 8%, that's 108%, and then we divide by 100 to work out our multiplier, and that gives us 1.08. So the company's income in 2017 can be X plus $500,000 or 1.08 multiplied by X. So that's 2 different ways of representing the same things using this sentence and this sentence here. And if they both represent the same thing, then they must be equal to each other. So 1.08x must be equal to X plus $500,000. Now this is just an equation to solve. Notice this is a 1x on the right hand side. So all I'm going to do here is minus 1x or minus x on both sides. That's why equation skills are really important all the way across the course. Now 1.0x minus 1x, that gives us 0.08x. Do a little bit of decimal subtraction. This cancels. This gives us 500,000. And then we want the x on its own. So what's the opposite of multiplying by 0.08? Well, divide by 0.08 on both sides. This cancels, leaving us with x here. And now we need to calculate 500,000 divided by 0.08. Again, please don't try and do this manually. Again, you probably could if you wanted to, but this is why we have the calculator. That's what it's there for. And this gives us then the answer in dollars in this case of 6,250,000, which we pop in for our final answer, like so. So with this kind of question, it's about staying calm, particularly the more difficult percentage questions. Read the information, write it as an expression or write it as an equation, and then work through the algebra. Staying calm, just writing down the information you have will go a long way to getting those top grades. So feel free to have a look through the mark scheme here as well and look at exactly where you pick up those marks. But again, these percentage questions, you can get a hefty 7 marks by going through these stages and going through these calculations carefully. And number 3 is quadratics. Again, you're going to see this a ton across the entire video, but I try and devote a whole chapter just to quadratics. And I go through exactly simultaneous equations, but also looking at it in a more geometric context. Okay, and on to quadratics, which is a big topic on the IGCSE course, and it can appear in fundamentally quite a lot of different ways. So I want to show you a few questions here, definitely towards the more difficult end, where they can have quadratics actually inserted. And one place they can do this is a simultaneous equation, and this one here, because we've got some squares in here, so x squared and y squared, this is known as a quadratic simultaneous equation. Now generally on IGCSE Maths A Edexcel, they'll set this up so substitution is usually the easiest approach to take when actually working out these quadratic simultaneous equations. Now what do I mean by this? Well, notice y is equal to 2x minus 3 here, the second equation. So in the first equation, wherever I see a y, I can replace this with the right hand side of this equation. So all I'm going to do is copy out the first equation, so equation 1 here. Wherever I see a y, I'm going to put a 2x minus 3. So this gives us then 3x squared plus, well, wherever I see a y, I put 2x minus 3. So 2x minus 3 all squared. So all I've done here, if I just highlight, is I've substituted this y here and this y later on with this 2x minus 3. I've replaced one with the other. I also have the other y to think about here, so I get minus x and then substitute this in. And this is quite a standard question, although quite a difficult question on the course. So at this point we need to get into those algebra skills here. So first of all we're going to expand some brackets. You've seen me do this in previous parts. Remember 2x minus 3 all squared is the same as doing 2x minus 3 times 2x minus 3. Remember that double hook, crab, foil, whichever way it helps you to remember. So if I do this fairly quickly, 2x times 2x is 4x squared, 2x times minus 3 is minus 6x, 3 times 2x is also minus 6x, minus 3 times minus 3, be careful here, is positive 9. So we can collect up these middle terms here. So we get 4x squared minus 12x plus 9. So wherever I see this, I can replace it now with this expression. So I get 4x squared minus 12x plus 9. And here we just have, you have to be careful of course with this, an expansion of a single bracket. So minus x times 2x is minus 2x squared. Minus x times minus 3 is plus 3x. Notice I'm slowing down with that kind of process because it's where students make the most mistakes. Now at this point with quadratics, and it's a standard procedure, we want everything to the left hand side so that the right hand side is 0. Before we do that, we're going to collect some like terms. So notice we have a 3x squared, 4x squared, minus 2x squared. So 3x squared plus 4x squared is 7x squared. 7x squared minus 2x squared is 5x squared. Then we've got the x terms, so minus 12x plus 3x is equal to minus 9x. And then we've got the plus 9 here is equal to 5. So again, simplifying down as we go along. Before we actually start to try and solve this, we're just going to make sure we get the right hand side 0. So we're going to minus 5 from both sides. Now remember that minus 5 has no effect on the 5x squared. It also doesn't have an effect on the minus 9x, but we do have 9 minus 5, which is equal to 4, like so, and then this side is 0. Remember, these two things cancel. So we've got a fairly tricky quadratic here to solve. Again, there's a number of different ways you can approach this. If you like the formula, so just to remind you what the formula looks like, I'll put it up here. X equals minus b plus minus the square root of b squared minus 4ac all over 2a. Again, you can use that approach, that's absolutely fine though. Many students just like the familiarity of using that. However, I'm going to take a factorising approach here, usually a bit quicker, better for you, again, when you go into A level and IB. So, first of all, I just set up my double brackets. Because 5 is prime, I know the only choice here is 5x and x, or the other way round. And then I think of the ways to get 4 here. So numbers that multiply give me 4. Well, it's going to be 1 and 4, 2 and 2, and then the negative version. So minus 1, minus 4, minus 2, minus 2. Now, the lazy approach here, which I recommend, I think it's quite useful here. Notice we've got a negative 9x here. So first of all, positive numbers then probably will not work. And then after that, having a look at which of these combinations it could be. Now notice the minus 9 is quite a bit more than 4, so I am more heading to where the two numbers are quite different. This kind of one way you can work these things out. And then a little bit of thought here. Thinks if I put minus 4 and minus 1 there, again I check the cross terms to make sure that works. So I mean cross terms, just these two multiplications. 5x times minus 1 is minus 5x. Minus 4 times x is minus 4x. Minus 5x minus 4x is minus 9x. So I do have the right factorization. That means then that either, using the null law or zero law, 5x minus 4 is equal to 0, in which case 5x is equal to 4, x is equal to 4/5. I'm going to put 0.8, mark scheme tends to like decimals on Edexcel, and x minus 1 is equal to 0, therefore x is 1. Now don't feel like at this point you have actually solved the equations. We've done the first part, so we've got x is equal to 0.8 add 1. We also need to work out the y values as well. And generally the easiest way to do this is substituting it into the bottom, more simple second equation. So when x is equal to 0.8, then y is equal to 2 lots of 0.8 minus 3. And that's going to be equal to minus 1.4. So y is equal to minus 1.4. And if we substitute 1 in, so 2 times 1 is 2, 2 minus 3 is minus 1. So make sure to get those 5 marks. You also work out the y values as well as the x values, because they do want you to solve it completely. Okay, and on to question 20 here, which is a nice question. It's kind of an unstandard completing the square question here, because notice it's not a pure complete the square. You have to do a little bit more work here in order to get in exactly the form that they want. Because notice we've already got a 7 out here, so we can kind of leave that alone for the time being. So the way I'd approach this is think of the 7 as sort of standalone, and then let's have a think about how we can actually factorize this. So imagine this is kind of separate here. It's the way to recommend. So first of all, I think by taking a common factor out, so if we take a common factor of 3, so if I bring a minus 3 out here, then what needs to go in the bracket and work backwards? So what do I need to multiply minus 3 by to get 12x? Well, minus 4x. And what do I need to multiply minus 3 by to get minus 3x squared? I need to multiply by x squared. So rather than just going headlong into this so-called completing the square form, I'm just sort of manipulating here and just making this look a little bit nicer. Now, the reason I've done that, and I'm going to swap this around here, so x squared minus 4x, I'm now going to use completing the square on its actual brackets itself. Now, I've done this, I think, in the previous part of this long video. So when I say about completing the square, what I'm looking to do here, so x squared minus 4x, is I find half of this term, so the minus 4, gives me minus 2. I pop it into a bracket like this. Now, if I expand this normally, I get x squared minus 4x plus 4, but I just want x squared minus 4x without the plus 4. So what's the opposite of adding 4? Well, minusing 4. So this here, underlined here, is the same as this. These are exactly the same expressions. So if you want more work on this, then if you type into YouTube, Ginger Mathematician completing the square, I go into far more detail on this topic. Now, all I'm going to do is replace the x squared minus 4x with x minus 2 all squared minus 4. And now I'm going to re-expand the bracket here. So what do I mean by this? Well, I'm just going to approach it as this times this and this times this. So if we times these things together, just put them together. And then minus 3 times minus 4 is positive 12. And now we just collect up the like terms. So we have a 7 and a plus 12. That's equal to 19. And notice, almost by magic, I've got exactly the formula I wanted. So in this case, A is 19, B is minus 3, and C is minus 2. So I saw this question, I put this in the video. Again, it's much more of a harder question than some of these in the entire video, just to show you that you can take this approach of isolating these two terms, completing the square, work backwards, and you'll get it in the form that you're looking for. So in this case, we get 19 minus 3 brackets x minus 2 all squared. Now, the reason they like you to put it in this particular form, so you're looking at the next part of the question, they'll tell you that a curve is equal to this, and I'm just going to write in the answer we just generated. So 19 minus 3, x minus 2 all squared. These two things are the same. And the point A is the maximum point on C. So a little bit of calculus in here. And use your answer to part A to write down the coordinates of A. So you have to use part A to work out the coordinates. Now, the great thing about this form, this is in what's called Vertex Form. And what this means is, if you want to read off where the vertex is, all we do is we take the number inside the bracket and switch the sign. So I switch that to 2. I leave the 19 as it is, and that gives me the x, 2, and 19, the y coordinates of that turning point. Now, your teacher might have taught you, if I just take the original equation here, plus 12x minus 3x squared, a method called differentiation, in which case if I differentiate this, 7 disappears, I get a 12, bring the 2 to the front, so you get minus 6x. And they've told you, okay, well, you can work out a maximum or a minimum point when this derivative is equal to 0. And so we solve this equation. Notice we then get x is equal to 2, the same as what we got in this question. And then to work out the y value, we just replace 2 in this equation to generate 19. But I'm really following the letter of the law here, so to speak, with the question, where it's getting me to use this answer in part A to work out these coordinates. But just to show you an alternative method that could be useful for you on this particular course. Okay, so you can see the answers from question 19 that I just did earlier, so the quadratic simultaneous equation. You can see you can take a variety of approaches here. So you've got the quadratic formula, you can also complete the square as well, whichever method you prefer. But I would try and encourage you, particularly for later courses, to be able to factorize really, really well. Question 20, we've just looked through too. Okay, and now on to, again, completely more different style of question. In this case, we've actually got some geometry in here, but also requires the use of quadratics. Again, all the questions we looked at in this section are the harder questions on the course. So we have a rectangle, so with these particular lengths, and we're given that the area of the rectangle is less than 75 square centimeters. And we need to find the range of possible values of x. So translating this question into something we can work with, if I work out the area, which is multiplying length times width, so this is 2x plus 3 times x minus 1, then this area needs to be less than, just less than, not less than or equal to, less than 75. So by using the information in the question, we've broken this down into essentially a quadratic inequality, which is linked, of course, to equations as well. We approach this as if we are actually doing a quadratic equation. So the way we do this is we expand the bracket out. Again, expanding double brackets is a big part of the course. So 2x times x is 2x squared. 2x times minus 1 is minus 2x. 3 times x is plus 3x. 3 times minus 1 is minus 3, and that's less than 75. Then we want to collect these like terms in the middle. So we have 2x squared minus 2x plus 3x is plus x. Minus 3 is less than 75. Now we're going to, again, approach it like a quadratic equation, which means we want the right-hand side to be 0. So what's the opposite of adding 75? Well, minusing 75 from both sides. If we do that, we're then going to get 2x squared stays the same, plus x minus 3 minus 75, that's equal to minus 78, which is less than 0. Okay, so now we've got our equation here, so let's write it up here. Imagine this is a standard equation to solve. So you've got 2x squared plus x minus 78 is equal to 0. Again, the approach I would convince you to try and do here is actually look at putting this into brackets. So 2x and x, and then looking at the factors that multiply to give us 78. Now, one thing to be aware of, we've got a plus x in the middle. So we're not really going to consider things like 1 and 78 or 39 times 2, for example, because the numbers are too far away from each other. We want two numbers that multiply, but also quite close to each other as well. So I'm going to ignore those. Notice 3 also goes into 78, so you can also divide through. Again, you should be able to do this kind of thing using short division. So 2 carried a 1, so 26 times 3. Now if 3 goes in and 2 goes in, then we know that 6 goes in as well. So we can also divide through by 6. So we get 1, made a 1, and 13. And looking at these numbers and going, 13 and 6, they're quite close together. 8 doesn't go in, so these are probably quite likely to be the numbers we're looking for. And again, we want to get this plus x in the middle. So with a little bit of thought here, if we put a plus 13 and a minus 6, again, we're going to double check this. So 2x times minus 6 is minus 12x, 13 times x is plus 13x, and then 13x minus 12x is plus x. So we do get what we want. Again, you can use quadratic formula, completing the square. That's an absolutely fine method. If you want more practice on this, if you type in IGCSE Algebra into YouTube, you'll find tons of practice I've done on the Cambridge course as well. Now we factorize this. We now need to work out what's called the critical values, because this is not an equation, it's an inequality, but we approach it in the same way. So the critical values, so first of all, either 2x plus 13 is equal to 0, therefore 2x is equal to minus 13, x is equal to minus 13 over 2, which is equal to minus 6.5, or x minus 6 is 0, x is 6. Okay, so we want this to be less than. So if we think of a sort of typical quadratic here, I'll pop this over here. And we've got our answers of 6 and 6.5. So like so. This is 6, this is minus 6.5. We want to be less than 75, so we want everything below the axis. So we're looking for this part of the graph. So 6 is going to be our upper bound. What we need to be careful of what is the lower bound. So many students, and this is the difference between an A and A star student, will just go, our our range is between minus 6.5 and 6. We're done. Boom. However, we need to be careful with this, because if we look at our quadratic here, notice when x is equal to 1, 1 minus 1 is 0, anything times 0 is 0, and 0 is less than 75. Okay, but we do need to think about, okay, can we actually have negative lengths of this? And notice if we have anything less than 1 here, so say we had x is 0, for example, then 0 would be equal to negative 1. And we can't have negative 1 centimeters. That makes no sense. So our lower bound here actually, and if we just pop this in, the top bound was 6, but our lower bound here has to be 1, because anything less than 1 and we start getting negative lengths that obviously don't exist in a real context. So this is where that extra mark, that 1, really does show the difference between an A student and an A star student. So getting that 6 and minus 6.5, an A grade student can do this, but noticing, okay, x has to be more than 1, and strictly more than 1, it can't be 0, means that you've actually answered the question you're given. If you look through the mark scheme, you can have a look at this. This is why I do these videos, because you'll see this answer kind of comes out of nowhere, but by going through this explanation I've gone through in this particular video, you've got a much better understanding of, okay, how do I apply my quadratics knowledge to this particular question? And number 4 is indices. Again, you only get a few marks on these kind of questions, but they come up consistently every year, sometimes even appearing twice on an exam paper. So let's go and check it out. Okay, and on to indices, which even though it's only a few marks on most of the exams, it does come up most years. So you really do need to know that, and you don't want to miss out on these 3 or 4 marks that could come up over the 2 papers. So first of all, we have write down the value of x to the power of 0. This is just a fact to learn. If you have anything, for example, we've got a smiley face like this one, to the power of 0, then that's just equal to 1. Anything to the power of 0 is 1. So just write down 1 and get that mark. That's really important. Now, given that 2 to the power of minus 3 times 2 to the power of 9 is equal to 2 to the power of n, find the value of n. Now, this is just a more complicated way of asking you how to work with indices. And if we have 2 to the power of minus 3 times 2 to the power of 9, remember when we're multiplying with indices, we add the indices together. So we do minus 3 plus 9. And if we do minus 3 plus 9, that's equal to 6. If you find negative numbers confusing, you can always use a temperature scale. So start at minus 3 and go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then count how much you go upwards, and then you get to 6. So essentially we want to work out the n here, and that's just going to be equal to 6. So we pop in 6 like so. This question works in a very similar way. So given that 7 to the power of 206 times 7 to the power of m divided by 7 to the power of 214 is equal to 7 to the power of minus 3, work out the value of m. So we approach this in the same way. So if we have 7 to the power of 206 times 7 to the power of m, that's just equal to 7 to the power of 206 plus m divided by 7 to the power of 214 is equal to 7 to the power of minus 3. Remember, when we're dividing with indices, it's the opposite, so we're minusing. So we can simplify the left-hand side. So we take what we had before, plus m minus 214, and that's equal to 7 to the power of minus 3. And if these two things are equal to each other, then this underlined here must be equal to this. Therefore, we use 3 dots of therefore, 206 plus m minus 214 is equal to minus 3. And again, this is just essentially equation solving. So 206 minus 214, that's minus 8. And then what's the opposite of minusing 8? Well, we want to add 8 on both sides. This cancels, leaving us with m. And then minus 3 plus 8 is equal to 5. So our final answer here, to get the 2 marks down here, is m is equal to 5. Now you can see the mark scheme there, again 1, 6, 5, and you can see how they've worked it out there. And they've used an equation method too. Okay, on to question 4 here. This is a question that I've been teaching IGCSE for many, many years. It's surprising how many students don't get all 2 marks on this first question. So we want to do 3k squared to the power of 4. Now, if we want to work this out, and this is what students always forget, the 4 applies to both. It applies to the k squared and it applies to the 3. So we can rewrite this as 3 to the power of 4 multiplied by k squared to the power of 4. Okay, now we need to really know our 3 times table. So 3 to the power of 4, remember that's the same as saying 3 times 3 times 3 times 3. 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81. So mental maths is still very, very useful at IGCSE. When we have brackets with indices, and we haven't looked at a situation like this yet, we just multiply the indices. So we just do 2 times 4, and that's equal to 8. So our final answer here is 81k to the power of 8. And on to question 4b. So we've got 21m to the power of 4n divided by 3n to the power of minus 5. The way to do this is do each part separately. So first of all, let's work with the numbers here. So 21 divided by 3, that's equal to 7. M's, we've still got just m to the power of 4. There's no m's in the other. So we still have m to the power of 4. And then we've got n divided by n to the power of minus 5. This is where it gets slightly tricky. Now, first of all, n on its own just means n to the power of 1. Remember, when we're dividing with indices, it's a minus. So we get n1 minus for the divide, but don't forget, we've also got a minus 5 here as well. So we have 1 minus minus 5. Now, 2 minuses next to each other become a plus. So we get 1 plus 5, and that's equal to 6. And all we're going to do is we're going to bring the 7, m to the power of 4, n to the power of 6 all together to make our final answer. So we get 7, m to the power of 4, n to the power of 6, like so. Okay, and last question here. So question 19 is, again, more tricky question. Notice you've got a high question number. It's usually a more difficult question on Edexcel. And we need to simplify 8 squared times the cube root of 4 to the power of 6 and give your answer in the form 2 to the power of a, where a is an integer. So remember, integer, important word, it comes up often. It means a whole number. So my approach to this kind of question is, well, we want it in 2 to the power of something anyway. Let's convert everything to 2 to the power of something. So what do I mean by this? Well, remember 8 is the same as saying 2 times 2 times 2, which is equal to 2 cubed. And 4 is equal to 2 times 2, so that's equal to 2 squared. So wherever I see an 8, I'm going to put a 2 cubed. Wherever I see a 4, I'm going to put a 2 squared. So if we do that, got an 8, so I'm going to put a 2 cubed to the power of 2. And now we've got the cube root, which we'll deal with in a moment. And then 4 to the power of 6. So we want 2 squared now to the power of 6. And now we can simplify in the same way that we've looked at before. Remember, when you have brackets with indices, we multiply them. So 3 times 2 is 6, so we get 2 to the power of 6. We will deal with that cube root, don't worry about it. And then 2 times 6 here is equal to 12, so we get 2 to the power of 12. Now we need to know about our roots, and we haven't really talked about this in the video so far. Remember a square root. So if I did the square root of, I don't know, 81, for example, we would know that's equal to 9, but we can also write this as 81 to the power of a half. Likewise, the cube root of 8, which is equal to 2, that's the same as saying 8 to the power of a third. So any root we can actually change to a fraction index. What does that mean here? Well, all we're going to do is we're going to put 2 to the power of 12, and then this cube root is the same as a third, so we do to the power of a third. Once we've done that, Do 12 times a third, that's just equal to 4. So a third of 12 is equal to 4. And therefore, 2 to the power of 6 times 2 to the power of 4 is equal to 2 to the power of 10. So therefore, I make it very clear to the examiner, A simply for the 3 marks is equal to 10. I'm going to write that in the answer place below, just like so. I also write this as 2 to the power of 10. But it's not entirely clear if they want you to write 2 to the power of 10 or just A is equal to 10. But I guess both would get you both 3 marks. Okay, and on to this question, again, much more tricky as well. Again, see a 4-mark question. You know, there's going to be a lot to do. So, given that n to the power of minus 4/5 is equal to a half to the power of 4, now n is greater than 0, find the value of n. Okay, so let's write this out first of all. So, n to the power of minus 4/5 is equal to a half to the power of 4. So what we want to do here is get n on its own. I mean, we often say this with equations, but specifically what we want is we want to get n to the power of 1 on its own. Again, we don't usually talk about that. So if I've got n to the power of minus 4/5, what do I need to multiply to give myself 1? Well, first of all, if I flip the fraction and do 5 over 4, that will certainly give me minus 1, but then I'll also need to put a negative here as well. So I'm kind of working backwards. I know what I want, but then I need to think, what do I need to multiply that minus 4/5 by so that it gets to something that I want? So what I'm going to do here is raise both sides to the power of minus 5 over 4. It's not a process you see that often. But hopefully you see the logic of it, and you'll see this in a later step where we actually just get n to the power of 1 on its own. So what I'm going to do, as long as you do the same to both sides, everything is fine. So minus 5 over 4, and that's equal to a half to the power of 4, all to the power of minus 5 over 4. Now, the point of doing this is that these two things cancel. Again, you see this idea again and again. So we get just n to the power of 1. And we can actually simplify this part here because 4 times minus 5 over 4, this just cancels. And then we just get minus 5. So we get 1 over 2 to the power of minus 5. So to work this out, actually it's not as bad as it looks. If we have a negative index, we haven't talked about this in this video yet, then we just flip the fraction and make this positive. So we get 2 over 1, or just 2, to the power of 5. And so all we need to do here is just work out 2 to the power of 5. And it's the same as 2 times 2 times 2 times 2 times 2. And that then gives us 32, which is our final answer. So by taking this approach, and hopefully you've got the thought process here, not just, okay, you've magically come up with minus 5 over 4. We want to get to 1, we just want n equals something. What do I need to do to minus 4/5? To get that, well, I need to multiply by minus 5 over 4. You see this in coordinate geometry where you look at negative reciprocals and this idea. Again, similar process, but approaching it in a slightly different way by looking at indices. So you can see the mark schemes here for the questions that we've gone through. So 81k to the power of 8, 7m to the power of 4, n to the power of 6. And you can see the different methods that they've taken actually for question 19b. But I think by raising both sides using this process here of minus 5 to the power of 4 is probably the most effective way to get to the answer. And number 5 is probability. And if you're expecting some easy questions in this section, you couldn't be any further from the truth. I really tuck into some really difficult questions to make sure you really understand the key topics, all things probability. Okay, and on to the probability section of this video. If this content's been really useful to you so far, then please do like and subscribe for more IGCSE Edexcel content in the future as well. Right, so let's have a look at question 6. In probability questions, there's usually quite a lot of reading to do and to go through and label the important information. So the bag only has pink, white, green and red sweets. There shouldn't be anything extra to our table. And we've got each of the probabilities that when a sweet is taken at random from the bag, the sweet will be green or the sweet will be red. So we've got those particular probabilities of 0.2 and 0.35. We're told that the ratio of pink sweets to white sweets are in the ratio 2 to 1. And there are 28 red sweets in the bag. Work out the number of white sweets. So a lot of information, and we just need to break this down one thing at a time. So the first thing to remember is that all probabilities add up to 1 or 1.00. So the first thing I'm going to do is work out then the combined probability of pink and white. So probability of pink or white is equal to 1 minus the probabilities that we know. So 0.2 plus 0.35. So 0.2 plus 0.35 is 0.55. And then 1 minus 0.55 is equal to 0.45. So we know that pink and white must add up to 0.45. They're also in the ratio 2 to 1. So essentially you want to split 0.45 in the ratio of 2 to 1. So the way that we do this is a standard process. We add the parts together. So we get 2 plus 1 is 3. Then we take the 0.45 and then divide that by 3. So 3's into 45 go 15. So 0.15. So therefore, the pink will be 0.15 times 2. So the left-hand side of this ratio, so that's equal to 0.3. And then the white ones, that's going to be 0.15 times 1, which is just 0.15. So we can pop this now into our table. Notice you should always double check this. Do these two things add up to 0.45? Yes, they do. That's absolutely perfect. Now we've got a number of red sweets. So we have 28 red sweets in the bag. So 0.35 is then related to 28 red sweets. Now we want the number of white sweets here. That's in the question. So we want to work out 0.15. and how many sweets that is. Now, I think the easiest approach to do this is that if we divide both sides by 7, you're probably wondering, where does the 7 come from? Well, I want a number that fits into 0.15. If I divide 0.35 or 35 by 7, that's going to give me 0.05. If I do the same thing to both sides, 28 divided by 7 is equal to 4. But notice, what do I need to multiply 0.05 by to get to 0.15? Well, I multiply by 3 on both sides. And 4 times 3 is then equal to 12. So rather than having to work out a total amount of sweets in the bag and then find 0.15 of it, I've used this relationship, this proportion, to then work out the proportion for 0.15. So our final answer here for the white sweets is equal to 12, like so. So you can have a look at the mark scheme here. You can see how they've approached it. Again, I've taken this idea of this here, and then you can work out the proportion from there. But I think by using this proportional method, you'll see this with variation proportion, which I don't think is in this particular video, but if you type in IGCSE variation proportion, you'll see me do lots of questions in a very similar way. And on to this question 23, which you know is going to be a hard one when you get to those high numbers. So Pippa has a box containing n pens, only black and red in the box, and the number of black pens is 3 more than the number of red pens. Pippa's going to take random 2 pens from the box. Notice no replacement here, so that's important to realise. And we're given the fact that the probability she will take a black pen followed by a red pen is equal to 9 over 35. So black followed by red only is 9 over 35. And from this, we're supposed to try and work out the possible values of the number of pens in the bag. So before I get into this, I'm just going to identify some of these facts here with a letter. So for example, I'm going to say the number of red pens, just give us something to work with here, is equal to x. And therefore that means the number of black pens, well, that's going to be 3 more than this, will be equal to x plus 3. So we then also know, because the box contains n pens and only black and red, that the total number of pens is equal to x plus 3, the number of red and black together. And that gives us the number of pens in total is equal to 2x plus 3. Now what I'm going to do here is do a little bit of rearrangement, so I have an expression for the number of red pens and number of black pens in terms of the number of total pens. So what do I mean by this? Well, basically with this, I'm going to make x the subject. Again, a very useful skill across the IGCSE syllabus. So what I'm going to do here is going to get the x on its own. So what's the opposite of adding 3? Minusing 3 on both sides. This cancels, giving us 2x is equal to n minus 3. And the opposite of timesing by 2, of course, is dividing by 2. So that then gives us that the number of red pens is equal to n minus 3 over 2. So this is another way of writing the number of red pens in terms of the total amount of pens available. We can also do a similar process for the number of black pens. So remember, the number of black pens is just x plus 3, and that's whatever the red pens were, which is n minus 3 over 2. And then we add on an extra 3. Now, to make this a bit more easy to work with, I'm actually going to combine these two things together with a little bit of unsimplifying. Remember, 3 is just the same as saying 6 over 2. So 6 divided by 2 is 3. And this now allows me to add the fractions together. So n minus 3 plus 6, that's equal to n plus 3 over 2. So to summarize what we've just done here, so red pens, that's equal to n minus 3 over 2, and black pens, that's equal to n plus 3 over 2. Okay, now we're ready to actually draw a tree diagram. You're probably wondering, why did I not start with that earlier? But I needed to have those facts in there before we have a look at our tree diagram. So we're going to have black, red, black, red, black, red. So the probability then of getting a black pen, because that's what we're focusing on here, is n plus 3 over 2 divided by the total number of pens that exist, which is n. So the top part represents the number of black pens, the bottom there represents the total number of pens. Now we can rewrite this to make this look a little tidier, which we'll do a bit later on. Now, given we've already chosen a black pen, what's the probability of choosing now a red pen? Well, we have n minus 3 over 2, so the number of red pens, divided by the total number of pens in the bag. Well, we've already taken a black pen out of the bag, so the total number of pens now is n, the total at the start, minus 1, because we've already taken a black pen. Now we can use the fact of the question here, that this probability, so the probability of black, red in this order, is equal to 9 over 35. So what we can say here is that if we take the n plus 3 over 2 divided by n, which we'll tidy up, multiplied by n minus 3 over 2 divided by n minus 1, this needs to be equal to 9 over 35. Okay, so let's now tidy this up and get this in an equation that we can work with. Now, I'll just give you a number example of what I'm going to do here. So say I had 2 over 5, and then I was dividing that by 3. I could write this as 2/5 divided by 3, which is the same as saying 2/5, keep it, switch it, flip it, times 1/3, which is equal to 2 over 15. So to simplify this, I can just take the 5 and 3 here and multiply those together and put in a denominator. Notice 5 times 3 gives us the 15 here. So what I'm going to do to tidy this up is just bring the 2 and the n together. And I can do the same thing at the bottom here. 2 brackets n minus 1 is equal to 9 over 35. At this point, I can multiply the fractions together. So we get then on the top, n plus 3, n minus 3. On the bottom, 2n times 2 is equal to 4n, n minus 1. And this is equal to 9 over 35. Okay, we're making progress here. We've now got an algebraic fraction that we can work with. I'm going to create another slide. I need a little bit more room here. So let's copy this across. So we've got n plus 3 over n minus 3 over 4n n minus 1 is equal to 9 over 35. Okay, so we can do cross multiplying at this point. So this times this, this times this. This then gives us 36n n minus 1 with 35. Now if we expand this bracket, this is a difference of 2 squares. So we can actually simplify this quickly to n squared minus 9. If you need to revise that, check out my algebra videos. I go through a ton of those kinds of questions. But again, you can just multiply this out using first outside, inside, last, a double eyebrow, etc. Then we multiply this out, so we get 36n squared minus 36n equals 35n squared. 35 times 9, so we get 5, 4, 315. Now we're going to bring everything now to one side. It's actually a quadratic, even though we saw this in section 3. We've got more quadratics to work with. So we're going to minus 35n squared from both sides. This hopefully will give us a quadratic we can work with. So we get 36n squared minus 35n squared. It's just n squared. Minus 36n is equal to minus 315. Add on 315 on both sides. And then we get this quadratic here. Okay, so now we have to look at how to solve this. Again, we could take the approach that we've looked at in previous questions, but I think in an exam setting it's not so obvious which factors of 315 work for minus 36. If you do get those, congratulations. So instead, I'm going to use the quadratic formula, which we haven't used so far in this particular video. So this is minus b, so 36 plus minus the square root of 36 squared minus 4 times 1 times 315 all over 2a. Okay, so 36 divided by 2 is 18, so we can simplify that down. If we pop the square rootiness into our calculator, 36 squared minus 4 times 1. I assume it's going to be something nicer. It is, it's equal to 6, so not square root of 6, just 6. That's nice. So 6 over 2. So that then gives us 18 plus minus 3. So our final answers here. 18 plus 3 is going to be equal to 21. 18 minus 3 is equal to 15. And those are answers. And both are realistic. If we go back to the question, you could have 21 pens or 15 pens. Both would make sense in context. Again, if you get a negative number, of course, that wouldn't make any sense. So you can look at the mark scheme there. Hopefully I've broken that down for you so you can see the steps going through. Again, this is an AA star question, so you're looking for those really top grades. This is the kind of question you need to be able to get a lot of marks on and picking up those method marks. Okay, and on to this question, 15, so a bit more of a medium star question. So Barney has a biased coin. When the coin is thrown once, the probability that the coin will land on heads is 0.3. Therefore, tails will be 0.7. Barney throws the coin 4 times. That's important. Work out the probability that the coin will land heads exactly 3 times. So let's think of the combinations here rather than using a tree diagram. So we have heads, 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 tails. Heads, tails, heads, 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 tails, heads, 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 tails. So there are 4 combinations where it lands exactly 3 times. To work out one of these, again, the probability doesn't change from throw to throw. So that's going to be equal to 0.3 times 0.3, 0.3 times 0.7. So if we pop this into our calculator, 0.3 times 0.3 times 0.3 times 0.7, we then get 0.0189. However, we're probably exactly 3h. We've got 4 combinations of this, so we take our answer and then just multiply that by 4, 189, and that gives us then 0.0756. So again, the key thing is about thinking it through logically, going, okay, there's 4 combinations of it, again, work out one of those and then you can multiply it by 4. Using the benefit here, there's no change in probability from throw to throw. Now B is an interesting question here. Work out the probability that the coin will land heads at least once. So instead of working out all the combinations, you can imagine all the combinations there, we're going to take a slightly different approach. Now we know all probabilities sum to 1. The only combination where it doesn't land heads at least once is tails, 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 tails. Every other combination has a head at least once. Now if we work out the combination of tails, 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 that's going to be 0.7 times 0.7 times 0.7 times 0.7. Again, I'm sure most of you are writing this down, hopefully. 0.7 to the power of 4. And we pop this in. So that gives us 0.2401. So to work out the probability, working backwards kind of heads at least once, rather than adding up all those combinations, we can then just do everything minus this one combination of tails, 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 tails. And if we pop that into the calculator, that then gives us 0.7599. Notice it's only a 2-mark question here, so just highlight this. So it should be a more straightforward approach than working out tons and tons of combinations. So do look for the most efficient approach to the question. So you can see the mark scheme there, and you can see where you pick up those marks. And number 6 is the area of 2D shapes. So a variety of different questions here, really try and challenge your understanding rather than just looking at the basic questions. Okay, how do you apply this in a much more complicated context? Okay, and on to our 2 main geometry topics. The first one here being the area of 2D shapes, but also applying it to different contexts. So Jonty's got a storage container here in the shape of a cuboid, and we're given the dimensions of it. And he wants to paint the outside of it. So as soon as I see painting the outside, I'm thinking surface area. So first thing that comes to mind here, outside of the storage container, apart from the base, which is shown shaded in the diagram. So he doesn't need to paint this, but he does need to paint the other sides. Okay, needs enough paint to cover the 4 sides and the top. So again, clarifying that we're looking for only 5 sides here, not the bottom side. That's important. Each tin of paint covers an area of 15 square meters. The cost of each tin of paint recently increased by 10%. After the increase, this is important, hence in bold, the cost of each tin of paint is £26.95. Jonty says before the increase, I could have bought enough paint for less than £200. Show that Jonty is correct. So the first thing I'm going to calculate here is the sides to paint, so the area of sides to paint here. So this way, be a little bit careful. So let's work out all the sides that we can see. So 2.5 times 3, that's 7.5. The same front and back. We've got this side here, so the 12 times 3, that's 36 front and back. And we've got that top side, so don't forget that as well. So that's going to be 12 times 2.5, and that's going to give us 30 at the top. So the total to paint here will be 2 lots of 36, that's 72, 2 lots of 7.5, that's 15, plus 30. So we add those together, we are going to get 117. Yeah, so 117 square meters to paint. Right, and now let's work out about the costs. So after the increase, the cost of each tin of paint is £26.95. So it's been increased by 10%. So 110% of the cost is equal to £26.95. And we want to find the original price of that. So we want to find 100%. This is the way I tend to do this. In German, we've got a Dreisatz procedure, so doing it in 3 steps. The way I'm going to approach this, if I divide both sides by 11, then that's going to give me 10% here. And then whatever this is, divide by 11, and then we can times by 10 to find out the price. So notice by structuring it in this way, you can do lots of different percentage questions in this way. So if I take 26.95, divide by 11, it's going to be 2.45, times that by 10, that's going to give me £24.50. So the original price, which is what we're interested in because we want to know before the increase, was £24.50 per tin of paint. Okay, so let's write that down. So cost of tin of paint. So summarize everything on this slide. This was equal to £24.50. Each tin covers 15 square meters. So if I do 117 divided by 15 on the calculator, that gives me 7.8. So I need to buy 8 tins of paint to cover the whole surface. If I do £24.50 and times that by 8, I sincerely hope that is less than 200. It is, good. So it's £196. So this is less than £200. John T. I want to write this very clearly. John T is correct. Okay, giving all the key information here. So from a marking point of view, they're looking for the cost of tin of paint. They're looking for the total amount to be painted, working out how many tins of paint need to be bought, and then the cost of that. So notice how I've structured that on this slide. So it's very clear for the examiner to tick this off, tick this off, tick this off, and give me then all 6 marks. You can see the official mark scheme here, and notice I've covered this, working out the sides, working out the total sides, working out the 24.5, and then working out the 7.8 or 8 part, and then calculating that through to give me the 196. So I'm picking up all those 6 marks just by explaining that very carefully as I'm going through. Okay, on to our next question here. So 16, so medium-ish question. So it shows a circle with center O, and ABC are points on the circle. So length of arc ABC. So the length of this here is equal to 5 centimeters. If only could work in radians, that'd be fantastic. Given the angle AOC is equal to 55 degrees, work out the area of the circle. And we want it to 1 decimal place. So with this in mind, the formula for the arc of a circle is equal to angle divided by 360. Worth remembering, this is on my IGCSE cheat sheet. If you type that into YouTube, you'll find it. So theta over 360 times the circumference of the circle, which is 2 pi r. Now at the moment we don't know what the radius is, so let's leave that as r. So the angle is equal to 55 divided by 360 times 2 pi r, and that's equal to 5. So essentially here we have an equation that we can rearrange. I think the way I want to simplify this down, let's combine this together here. So 55 times 2, that's 110 pi r over 360 is equal to 5. And therefore we want to multiply by 360 on both sides Again, try and get that r on its own, which is the most important thing. If we do multiply by 360 on both sides, this cancels, leaving us with 110 pi r, and 360 times 5. So we'll just use your calculator, there's no need to do anything else here. And then we want to divide by 110 pi on both sides. This cancels, leaving us with the radius, 1,800 by 110. So we can kind of leave this anyway as 1,800 over 110 pi. Again, if we want to work in decimals, that's absolutely fine as well. Just make sure we write down a lot of decimals though, so we don't get any rounding errors. Yep, so the radius here to 5.208707. Always be paranoid, always write down more than you need. And we want to work out the area of this circle. So the area of the circle is just equal to pi r squared. So we take pi times this radius, which is 5.2087 ... squared. Now, the great thing with your calculator, I've got this in my calculator here at the moment. All I need to do is go to the answer button and then press squared. So it will take all those decimals that are very, very useful. All I need to do then is times by pi. I get an answer of 85.233 ... And we want the answer to one decimal place. Again, read that question carefully. So 85.2. And we want area, so we want centimeters squared. Just be really careful in that accuracy at the end, making sure we're getting one decimal place. We've got square centimeters. We've looked at the units here used as well. So that's really, really important to make sure that you've got. Okay, so we've got the answer there, 85.2. Again, when they tend to mark these papers, they'll look for the answer. If they've seen that with supporting working, they'll give you all 4 marks, like so. Okay, and on to the last question here with the area of 2D shapes before we look at 3D shapes. The region shaded in the diagram is a path. The boundary of the path is formed by 2 semicircles. That's useful to know. Same center and 2 straight lines. Inner semicircle has a radius of 7. So if this is 7, then by definition this needs to be 7 meters as well. The path has a width of 2 meters, and we want to work out the perimeter of this path to 1 decimal place. So the perimeter, remember, is the distance around the outside. Notice we've already know these ones here. These are both equal to 2 because the path is the same all the way around. So the only things that we need to work out here, so I do this in a different color, do this in green. I need to work out this length here. And I also need to work out, we'll do this in blue, this length here as well. Remember, these are both semicircles. So let's work out the blue length first, since I've got the blue pen here. Well, we want essentially the circumference of the circle, but then divided by 2. So remember, the circumference of a circle is 2 pi r, or pi d. So we want 2 pi times 9. Notice if we take this entire distance, that's equal to 9. 7 plus 2 is 9. But we do want to divide by 2 because we have a semicircle. And we can simplify this down to just 9 pi. Now we can do something very similar with the green length here. Notice I'm leaving it in terms of pi. I don't feel any need to rush to my calculator. Again, this is going to be similar here, so we've got 2 pi r, so 2 pi times 7 this time, divided by 2. Again, these cancel, giving us 7 pi. So our perimeter, forget my red pen out now, is equal to the blue length and green length added together, so 9 pi plus 7 pi, adding in these extra 2 lengths here as well. So adding in 4. And only at this point do I rush to my calculator and go, okay, 9 pi plus 7 pi is 16 pi plus 4. And then we generate our answer here of 54.2 0.65. Making sure, see, I use exact values where I can to make sure the answer is the most accurate possible. And that gives us then 54.3 meters. Again, it's a length, so we just want meters there to one decimal place, like so. Okay, so you can check the answer here. Again, they're quite reasonable though, give you between 54.2 and 54.3. Again, you can see I've tried to keep, just like in the mark scheme here, to exact values where possible. This means you'll minimize those rounding errors as you go through. And number 7 is the volume and surface area of 3D shapes. So linked to the previous section, but again, I want to cover things like Pythagoras, for example, and again, looking at these unfamiliar style questions. Okay, and on to volume and surface area of 3D shapes, but you know, other topics will be fed into this as well. So we have a triangular prism here, and we want to work out the volume of it. So that seems like on the surface a straightforward question. Remember to find the volume of a triangular prism. All we need to do here is do length times width times height, but then divide by 2. Because notice we've got almost like half a cuboid in this case. The only problem with this, however, is that we're missing this side. So we need to have the 7.4 times 15 times this side. So we're kind of missing that at this point. However, we can actually work it out. Notice we've got 11.2 centimeters along here, and we have a right angled triangle. So if I draw a sketch of this a little bit more separately, notice that we have essentially in 2D 7.4 centimeters, 11.2 centimeters, and we want to find this side. As soon as you start seeing things like this, you should have Pythagoras going off in your brain. Pythagoras, Pythagoras, Pythagoras. Now, what do I mean by Pythagoras? I mean a squared plus b squared is equal to c squared. Now, certainly at IGCSE level, I want to keep things as straightforward as possible. So, to work out x, all we need to do here is the square root of 11.2 squared minus 7.4 squared. One easy calculation showing our method, but also keeping it efficient. Now, the reason that we are minusing here is because we're looking for a smaller side. We're not looking for the hypotenuse. So I'm going to plug this into my calculator. So the square root of 11.2 squared minus 7.4 squared. And this gives me, as a decimal here, 8.40713. Again, I'm going to write lots of decimals down so I can use it later. And now we can actually work out the volume of this prism by taking the dimensions here. So 7.4 times 15 times our new answer here. So this 8.40713 dot dot dot. But remember, we've got a triangular prism, so we need to divide all that by 2. Now the great thing is I can use the answer key here. So we include all those decimals. So answer times 7.4 times 15 divided by 2. And that will give us our final answer of 466.596 dot dot dot. Notice we want to 3 significant figures. They like it on IGCSE Edexcel, changing that rounding, 1 decimal place, 2 decimal places, 3 sig figs. So remember to do 3 significant figures, first, second, third. We want to round from here, 5 rounds upwards, so we get 467 volume. So we're looking for cubic centimeters to 3SF. It's imperative, it's really important that you are rounding to the correct amount. So you'll see the answer here. Again, for a 5-mark question, I think that's quite generous. Essentially, we're just using Pythagoras and then using the triangular prism formula. Right, on to our next question, which is going to bring back some quadratics and some calculus as well. So you're getting some of the other topics integrated into here. So we have a solid cuboid. So we have x, x, and then 12 minus 3x. The total surface area of the cuboid is a centimeters squared, and we want to find the maximum value of that. Okay, so what we want to do is consider how do we actually work out an expression for the total surface area. Well, notice we've got the base here, so that's x times x, that's x squared. and then we've got x squared at the top here as well. And then if we take the remaining sides, we have x lots of 12 minus 3x for this side, and actually all these sides will be equal to that. So this one here, this one here, and then the one at the front here, x 12 minus 3x. So the total surface area, so A in this case, is equal to, well, x squared plus x squared is 2x squared, and then we have 4 lots of this x brackets 12 minus 3x, like so. Now we can just do some expansion here. So we're going to expand out the bracket, just a single bracket here. So 12 times 4x is 48x, and 4x times minus 3x is minus 12x squared. And if we collect up the like terms here, we get 2x squared minus 12x squared is minus 10x squared plus 48x. So what we've done here is we've written an expression for the total surface area of the cuboid in terms of this length x here. Again, usually the first step in such a question like this. Now at this point we're looking for the maximum value. As soon as you see maximum value in a question, we need to be thinking calculus and differentiation. So let's see what we're going to do right over here. What we're going to do is find the first derivative of a with respect to x. So we're going to derive this function here. So just to go through the steps of a bit of calculus here, to derive it, we take the 2 here, we bring it to the front, and do minus 10 times 2, that's equal to minus 20, and reduce the index by 1. So we did have x squared, now we're just going to have x to the power of 1, just x. When you have x to the power of 1 to start with and differentiate, all we need to do is take the coefficient in front of the x. So we just take the plus 48. So we found our first derivative of this particular surface area. What we're going to do at this point, if we want to find a maximum point or a minimum point, we set it to 0. So essentially what we do here, we set dA over dx equal to 0. That means then minus 20x plus 48 is equal to 0. That means then that 20x is equal to 48. X is then equal to 48 divided by 20. Again, we just use our calculator for. They do like decimals, generally speaking, on Edexcel, so we get the value of x being 2.4. Now, a lot of students at this point think, yes, I've got the answer. I know x is 2.4. I'm finished with the question. Not quite. We're looking for the maximum value of a. We're not looking for x, we're looking for a. Now notice we've already got a formula for this. Remember, a is equal to minus 10x squared plus 48x. So we now know when x is equal to 2.4, sorry, we can then get our maximum area. So our max A is minus 10 lots of 2.4 squared plus 48 lots of 2.4. Again, you could do this, without a calculator, but why not just use the calculator carefully, just so we can avoid any of those silly mistakes. And if you pop it in, you'll then get the answer of 57.6. So that's the actual answer here, the maximum value of A, which is 57.6. Remember units, no units here, 57.6 square centimeters. So notice, even with these sort of volume questions, we've got some quadratics in there, we've got some calculus in there. So just be aware of those high-level questions. You do need to have a good understanding of the entire syllabus. So you can see the answer here, so 57.6, and then the working associated with that. And on to our next question, again, question 21. So it's going to be a harder question here. So the diagram shows a solid made from a cylinder and a hemisphere. So cylinder here and then the hemisphere here, half a sphere. Both made from the same metal. The plane face of the hemisphere coincides with the upper plane of the face of the cylinder. So that's a complicated way of saying that this matches up with the hemisphere above it. The radius of the cylinder and the radius of the hemisphere are both x. Okay, good to know. The height of the cylinder is 3x centimeters. Lots of information in this question. The total surface area of the solid is 81 pi square centimeters. The mass of the solid, okay, so density is probably going to be involved. It's 840 grams. And the following table gives the density of each of the 4 metals. So we've got those there. The metal used to make the solid is one of the metals in the table. We need to work out what it is. Right, so the first thing we need to do is work out what this x is first of all. So first of all we want to work with surface area. So the surface area of a cylinder, or I should say the curved surface area, and we can add in the base later, is equal to 2 pi r and the radius, which is x in this case, so 2 pi r h, sorry, and the radius is equal to x, so we have 2 pi x, and the height is equal to 3x. Okay, so if we simplify this down, we get 6 pi x squared. So that's this part done, the curved surface area. Then we need the bottom part of this, which is just a circle. So the circle at the bottom is just pi x squared. Then we've got this hemisphere at the top here. So the surface area of the hemisphere, again, these are formulae you need to know, but again, you can use formula sheet, is 4 pi r squared for the sphere, but then we want to divide by 2 because it's a hemisphere, so we get 2 pi, in this case x, so 2 pi x squared. So we've got the curved surface area, which is this part, the circle at the bottom, the surface area of the hemisphere. So we add those together, the total surface area is equal to, well, 6 pi plus 1 pi plus 2 pi, that's 9 pi x squared. And that's also equal, because we're given this in the question, the total surface area is equal to 81 pi. So we've got a very nice equation here. We've got lots of cancellation. We have a pi on both sides. 9 divides through on both sides. So we get the very nice equation out of this. X squared is equal to 9. So the opposite of squaring, of course, is square rooting on both sides. And that gives us the value of x to be 3 centimeters. So that's the first part of it here. So we've got x is equal to 3 centimeters. Now we need to think about volume. Now, why am I talking about volume in this question? Well, there's a formula you need to know on this course specifically for IGCSE Edexcel, and that is density is equal to mass over volume. Some of you may have approached this with this triangle here, it's this DMV triangle, which is useful to know. So we're told the mass of the solid is 840 grams. In order to work out the density of this, we need to work out the volume so we can work out which of these is correct. So our next task is to work out the volume of the shape. So we divide this into 2 parts. So the volume of the cylinder, so this part here, well, this is equal to pi r squared h. Now we know what the radius is. Now it's 3, and we know 3 lots of 3 is 9. So we know this is equal to pi times 3 squared times 9. So that's going to give us 81 pi. Notice I'm not rushing to my calculator at this point. Then we want the volume of the hemisphere, hemi for short, which this is equal to 4/3 pi r cubed divided by 2, because we've got a hemisphere, not a full sphere. So that's essentially 2/3 pi r cubed. And in this case, we know what the radius is. It's 3, so we get 3 cubed. And again, we can pop this into the calculator. This will simplify down to 18 pi. Again, we can cancel a 3 out. 3 squared is 9. 9 times 2 is 18. So the volume of the shape and this is in centimeters cubed or cubic centimeters. Okay, that's going to be equal to these two added together, so that's 99 pi centimeters cubed. Okay, so if we want to work out the density at this point, then we've got the mass. Notice you always have to check the units here. Mass is in grams, this is in grams. Cubic centimeters, this is in cubic centimeters. So the density will be equal to 840 divided by 99 pi. And this is finally where we actually have to use our calculator. And this is where we certainly hope that we get one of the answers in our table. So we get the answer of 2.7 grams per cubic centimetre. Do we have 2.7 in our table? We do. Excellent. We have aluminium. So our final answer will then be equal to aluminium, like so. Right, so you can have a look through the mark scheme and you can see all the steps that I've taken here. Again, it's 99 pi that we did earlier, getting x is 3, working out the 2.7 from what we just did. Again, trying to keep things in exact values will make your life a lot easier to avoid all those rounding errors. And number 8 is sequences and series. I know I've quite a few requests for this kind of part of video where we go through how to use the sum of an arithmetic series to actually answer quite the more complicated questions at the end of the paper. Okay, on to our section on sequences and series. This is particular to IGCSE Maths A Edexcel, as I do expect you to understand how to work out the sum of an arithmetic series. So this is straight from the formula sheet, and you'll see the formula here. So Sn equals n over 2, brackets 2a plus n minus 1d. Now just to go through some of the notation here. So a is equal to the first term in the sequence, and d is what we call the common difference, so how much the sequence is going up or down. N here represents the number of terms, so 5 terms, etc. Let me just give you an example, so a little bit of pre-teaching here before we look at some quite complicated questions. So say I've got the sequence of 4, 7, 10, 13, etc. Then the first term here would be 4. The common difference is what we're adding each time, so this is plus 3 plus 3, so d is equal to 3. And if I wanted to work out the sum of all these numbers that I put in the box here, so to work out S4, because there's 4 terms in the sequence, then we just replace the n with a 4, so 4 over 2, 2 lots of the first term, so 2 lots of 4, plus, well, there are 4 terms in the sequence, so 4 minus 1, and the common difference is equal to 3. And at this point, we just work this out. So 4 divided by 2 is equal to 2. 2 times 4 is 8. 4 minus 1 is 3. 3 times 3 is 9. And if we work this out, we'll then get the answer of 34. Now notice you could have done that by just adding all these together as well. That would also give you the answer of 34. But on this course, you're expected to know this formula and be able to apply it. Now I'm going to go through 2 quite difficult questions. One is right at the end of a paper 1, so you can see this kind of thing in action. But a little bit of pre-teaching I think is worth it here, just before we look at some questions. So this is question 23, so the second to last in this case. The sum of the first n terms of an arithmetic series, S, is equal to 292. So what they're saying here is that Sn, and we don't know what n is in this case, is equal to n over 2, in that formula we just saw on the formula sheet. And we're told that this whole thing is equal to 292. So keep that in mind. We're going to do a first part of the question and come back to this. The second term of S is 8.5. The fifth term of S is 13. And we need to find out what this value of n is. Now remember, any arithmetic sequence or series can be built up as first term plus 1 difference, first term plus 2 lots of the difference, first term plus 3 lots of the difference, and so on. And if I write this out and fit these numbers into here, well, the second term is this one, so 8.5, and the fifth term, which is 1 over here, is 13. So we know from this structure of making a sequence or series is that a plus 4d is equal to 13 and a plus 1d is equal to 8.5. Notice by writing it in this way, I've actually generated a simultaneous equation. So all we have to do is subtract one from the other. You've seen this many times in the equations part. A minus a disappears. 4d minus d is 3d. And then we do 13 minus 8.5. I mean, this seems very silly to do this on the calculator, but I recommend just double checking things. Yeah, there's no reason why not. That's equal to 4.5. And then we want to get d on its own here. So divide by 3 on both sides. This cancels, giving us d is equal then to 1.5. And once we know this is equal to 1.5, we can substitute back in one of the equations. You've seen this idea before. So we get a plus 1.5 is equal to 8.5, and therefore a here must be equal to 7. Like so. So we've worked out a is 7 and d is 1.5. You can always check this by putting the numbers back in. So adding on 1.5s, and you'll see you'll get to 13 at this term here. Once we've got this, then we can use this formula at the top here. So we don't know what n is for the moment, but we do know a is equal to 7. Don't know what n is, but we do know d is equal to 1.5. So we get a kind of messy equation out of this. So let's do some simplifying in the bracket first here. So we'll leave the n over 2 for the time being. 7 times 2 is 14. If we expand the bracket here, we get plus 1.5n minus 1.5 equal to 292. We can tidy up what's in here. 14 minus 1.5, that's equal to 12.5. And at this point, we'll now deal with this divided by 2. And there's a common tactic in these kind of questions, just to multiply the whole equation by 2. And that will remove this fraction and cancelling through. So we get n brackets 12.5 plus 1.5n is equal to, then we do 292 times 2, so that's 584. So let me copy this across to my next slide here, seeing it's a 5-mark question. So we get n brackets 12.5 plus 1.5n is equal to 584. We'll multiply out the brackets, again just taking our time here. So we get 12.5n plus 1.5n squared is equal to 584. I generally don't like decimals, so I'm actually now going to multiply by 2 on both sides. That then gives us 25n plus 3n squared is equal to, there we go, 584 times 2, 1,168. Yet again, we have got a quadratic that we need to solve. Again, we want to bring everything to the left-hand side. So we're going to minus 1,168 on both sides of the equation, giving us then 3n squared plus 25n minus 1,168 is equal to 0. And again, we have our choices of method here, whether we want to try and factorize and give it a go. I think here, with this very big number of 1,168, I am much more inclined here to use the quadratic formula. So we have x is equal to minus b plus minus the square root of 25 squared minus 4 times 3 times minus 1,168 all over 2a, so that's equal to 6. So let's simplify down this square root here. This is where the calculator comes in handy. So we get the square root of 25 squared minus brackets 4 times 3 times 6, 8, close brackets, giving us, oh, don't even need the square root here, 121. It's always a good sign when this is a whole number, divided by 6. Now we have our two answers, the plus minus. Notice if we take the minus answer here, we will then get a negative number, which if we go back to the question, doesn't make any sense in the question because we want the first n terms. So it needs to be a positive number. So I'm going to take the answer with the positive 121 divided by 6. Well, I don't know if you factorize this, by the way. It's probably not the easiest thing to factorize in the world. And then I'm getting the answer here of 16. So this is the only answer that works here. Again, we can always look at the question here, find the value of n. That gives you a clue that one of the answers will not be valid. So do use the question to guide you through to the correct answer. So you can see the solution there. They've also used a quadratic formula, which is a very sensible approach here, giving us the answer of 16 at the end. And if you thought that was a difficult question, I've got an even more difficult question for you on this topic. I'm really focusing on some of the harder questions in this video, so you're really well prepared for the hard questions that could appear in the exam. So an arithmetic series has first term A and common difference B, so we've seen that idea before. Now the sum of the first two n terms of the series is 4 times the sum of the first n terms of the series. Right, we're going to have to unpackage that in a moment. And then from that, we need to get a in terms of d. So what we're looking for at the end is a is equal to something plus, I don't know, something d, for example. Okay, so we want the sum of the first two n terms of the series. So if we go back to our formula, imagine that I just replace, I'll get the highlighter out, n here, and n here with a 2n, and keep everything else the same. So that's what I'm going to write down now. So we have s of 2n, so we then get 2n over 2, 2a plus 2n minus 1d. So notice wherever I saw an n before, I'm now putting a 2n. And what this question is saying is that this is equal to 4 times the normal formula. So 4 times n over 2, 2a plus n minus 1d, where a and d are the same in both formulae. So we get quite a messy thing to work with here. The first thing I would want to do is just cancel this through. So we get n brackets 2a plus brackets 2n minus 1d. We can cancel this through as well. 4 divided by 2 is 2. So we get a 2n, 2a plus n minus 1d. So we get a little bit of cancellation here as well. Notice on both sides of the equation we have an n, so we can cancel that through. So that gives us then 2a plus brackets 2n minus 1d is 2 lots of 2a plus n minus 1d. Okay, so at this point I think I'm just going to expand on the right hand side. So 2a plus 2n minus 1d is equal to 4a, so I'm just multiplying a single bracket here, plus 2d bracket n minus 1. Okay, and let's expand some brackets again. So we get 2a plus 2nd minus d is equal to 4a plus 2nd minus 2d. Okay, so we can at least cancel this on both sides. We can minus 2a now from both sides. So this cancels here. So we're left with minus d is equal to 2a minus 2d. And if we add then 2d on both sides, minus d plus 2d is just d, and that's equal to just 2a. This cancels. And we want a in terms of d, so we just need to divide by 2 on both sides and that gives us a is equal to d over 2. So all that's saying is the first term is half of the common difference in order for this to be true. So our final answer here is this a is equal to d over 2. The key thing with this kind of question is not to panic. Just take your time, write it out exactly as I did there, see what cancels, keep working on it, and eventually you will get to the right answer. But you have to have faith in these kind of questions to make sure you are getting there to the right answer. So you can see the mark scheme here. So you can see that we get to d over 2 at the end there. And number 9 is coordinate geometry. You didn't think the coordinate geometry would be missing from this video. So looking at things at gradients, y-intercepts, and there's a really nice question at the end of this part, which covers a lot of different areas of this topic. Okay, and on to our next section here on coordinate geometry. So we're going to go through some basics in the first 2 questions and then a really tricky question towards the end as well. So we have question 13 here. Point A has the coordinates 5, 8. Point B has the coordinates of 9, minus 4. And we want to work out the gradient of AB. Now, there's different ways we can approach this. I think most people use this idea of y2 minus y1 over x2 minus x1, a formula that you do need to know. And if we want to label our coordinates here, so this would be our x1 and y1, this would be our x2 and y2, and that's just about putting in the formula nice and carefully. So y2 is minus 4, y1 is equal to 8, divided by x2 is 9, minus our x1, which is 5. So very careful with negative numbers at this point. Minus 4 minus 8 is equal to minus 12. 9 minus 5 is 4. And that gives us minus 12 divided by 4 is minus 3. Again, you can always draw a sketch to help you with this kind of question, or just use the formula like we've done here. Now, the straight line L, something completely different, has the equation y equals minus 4x plus 5. Write down the gradient of a straight line that is perpendicular to L. As soon as I see this word perpendicular, I'm thinking negative reciprocal. Hopefully this is a phrase your teacher has used on the course. Now, what does this actually mean? Well, we take the minus 4, we flip it, so we do 1 over 4, and then change the sign, so minus to plus or plus to minus. So in this case, it started as a minus, so we want it to be a plus. Therefore, the perpendicular gradient, which we'll see in a later question how it's actually used, is equal to 1/4. And you really want to be picking up these kinds of marks, 3 marks, middle of the paper, making sure you get those C grade topics and B grade topics secure. On to another fairly straightforward question here, so question 10. The straight line L has equation 2y plus 7x is equal to 10, and we want to work out the gradient of L. Now remember, the straight line has the general form of y equals mx plus c, where this m is what we're looking for in this question, the gradient, and the c is what we call the y-intercept, which we'll talk about a bit later on. So we want it in this form. Notice it's not in this form at the moment. We've got the x on the wrong side of the equation, and we have a 2y. So we're going to do something that we've done in other topics, which is make y the subject. Now, how do we do this? Well, let's do it one step at a time. We're going to get rid of that plus 7x, because what's the opposite of adding 7x? Minus 7x on both sides. This cancels, giving us 2y is equal to minus 7x plus 10. And we're so close at this point, but unfortunately we still need to get rid of that 2. So what's the opposite of multiplying by 2? Well, dividing by 2 on both sides. This cancels, giving us y. Now we need to divide both of these things by 2 here. So we've got then minus 3.5x. Remember, minus 7 divided by 2 is minus 3.5. And then 10 divided by 2 is equal to 5. So the gradient of this line is this number in front of the x, the coefficient. So this is our minus 3.5. And in fact, we've got 2 for 1 here because it wants us to work out the coordinates of the point where L crosses the y-axis. By definition, the y-intercept is where it crosses the y-axis. So we know it crosses at 5. So we pop in 5 here for our y value, and our x value has to be 0. If you think about it, if you've got any point on here, the x value by definition has to be 0. So again, you can always draw a sketch to help you visualize this kind of question. Again, another 3 marks, easy marks you can pick up on this kind of paper. However, it's not always this straightforward, and our question 20 here is one of those kinds of questions. So we've got the straight line L, and it passes through these particular points, A and B. The straight line M is perpendicular to L, so using what we did in the first question, and passes through the midpoint of A and B. Okay. The line M intersects the line x equals -1 at C, and somehow we need to work out the area of the triangle. Okay, whenever you get a question coordinate geometry wise like this, just draw a diagram, particularly as it's worth 7 marks, so you want to make sure you're getting as many method marks as well. So let's draw a nice big diagram. Again, I don't have a ruler here, you should use a ruler. And we'll call this y, call this x, and let's make it at least reasonably to scale here. So we've got -6 and 2, so -6 along and 2 up, so we'll pop A here, -6 and 2. 5 and 3 is going to be roughly the same along, a little bit further upwards. So let's draw in our B. Don't be afraid of big diagrams as well. And this is our straight line L that connects up A and B and carries on. And the straight line M is perpendicular to L and passes through the midpoint. So we need a midpoint. This seems pretty suitable here. And how do we actually find what this midpoint is here? Well, we find halfway between -6 and 5. One way you can do this, finding the average of it essentially, is you just do -6 plus 5 divided by 2. That will give you -0.5. So this midpoint at -0.5. And the same with 2 and 3. Halfway of 2 and 3 is 2.5. But you can also use this formula to generate 2.5. Okay, so we've got our midpoint. That's very helpful. We actually need to get an equation of this line, this straight line M. It's perpendicular, so if I use a different color here, it's going to be a very steep line, like so. And perpendicular means it's at a right angle, so this is a right angle here. So probably want to work out the equation of this line because we want to work out, if you use a different color, so it intersects the line x equals -1 at C. So it's going to be just to the left of it here. If I draw a straight line. So this is the line x equals -1, the vertical line, and it's meeting this green line at C. So you can see we're building up a picture here, but we really need to know what this coordinate C actually is. And to do that, we need to go through a fairly standard procedure here, which is we need to work out the gradient first of all of AB. And we do it the same way we did before. So we use this y2 minus y1 over x2 minus x1. So y2, again, doesn't matter which way round we do this. Let's call this 3 minus 2 over 5 minus, be very careful with negatives, minus 6. So this then gives us 3 minus 2 is 1, and 2 negatives make a positive. So this gives us 1 over 11. You should always check this. Does this look like 1 over 11? Yeah, it's a very, very, very shallow line upwards, so that makes sense. So it means this green line is going to be a crazy gradient here. So in order to work out the gradient of M, it's that negative reciprocal, as you've seen before. Flip the fraction, so 11 over 1, and change the sign, so negative. So the gradient is going to be negative 11, which makes a lot of sense because it's a very, very, very steep line. Now, the equation of that line is going to be y equals minus 11x plus c. Remember, this minus 11 represents the gradient. We are missing this y-intercept, but we can work this out by using the midpoint. So when x is equal to minus 0.5, y is equal to 2.5, so that gives us then 2.5 equals minus 11 lots of minus 0.5 plus c. So 2 negatives are positive, so that gives us 5.5. If we minus 5.5 from both sides, we then get c to be negative 3. So we've actually worked out the equation of this line, minus 11x minus 3. Again, always check, is the y-intercept minus 3? I could definitely believe it from our sketch here that it is minus 3. Now we need to work out where it intersects with c here. So we know the x-coordinate, that's minus 1 from the line. Now we need to work out the y-coordinate. So when x is minus 1, we put it into this formula here. So we get minus 11 lots of minus 1 minus 3. That gives us 8. Again, does that make sense from our diagram? Again, I could definitely believe that too. Okay, so we've got then some facts here that are going to be useful for us. What we want to find is the area of this triangle. Now, the thing to notice here is that this line is perpendicular. So we can actually use the formula here for the triangle at half base times height, where the base is this long length from A to B, and the height is this length MC. So before we do anything here, we actually need to work out these lengths. I'm going to need another slide to do this. It's a big question, 7 marker. You can see why. So in order to work out the length AB, we're just going to use Pythagoras essentially. So to work out the length of AB, so imagine, I'll draw out a sketch again. This is minus 6 and 2, is that right? This is 5 and 3. So imagine you draw a right angle triangle here of AB. This length here, what do you do to minus 6 to get to 5? 11. What do you do to get to 2 to 3? Again, fits in with the gradient what we did earlier. So the length of AB will just be equal to the square root of 11 squared plus 1 squared. We've seen Pythagoras before, and that's equal to the square root of 122. And now we do a very similar process with MC. So again, I'll do a nice little sketch over here, then a slightly shorter line. So M was minus 0.5, 2.5. C here was minus 1 and 8. So again, we've got our little triangle that we can draw in here. So this is going to be 0.5. This is going to be 5.5. Yep. So therefore, that MC, wait for the MC hammer comments. If you got to this part of the video, congratulations. So we have 5.5 squared plus 0.5 squared. Pop this into the calculator. So the square root of 5.5 squared. And this gives us square root of 122 over 2. Okay, and now to work out the area of the triangle, it's a half base times height, so a half times the base, which is root 122, times the square root of 122 over 2. So if we pop this in, and we get 30.5 exactly. So 30.5. And doesn't tell us about units here, so we can just leave it at 30.5. That's absolutely fine. Perfect. Okay, so you can see the mark scheme here. We've done it a very similar way to this method, so the very first method that they presented. However, there are 4 other different ways of doing this actual question. So whenever your teacher says you need to do it this way or this way, this way, There are plenty of ways of approaching this. You can be using sine and cosine if you so wish with this kind of question. And the last section here is algebra skills. So I wanted to cover things like factorising, expanding brackets, inequalities and solving linear equations in a small section, because I think this always comes up every year. Although it's not that many marks and not that complicated, it's worth putting a little bit of emphasis on. Okay, and on to our very last section here, which is on algebra skills. I want to cover as much as I can in this particular video. So it's going to include skills like expanding brackets, factorising, solving linear equations, inequalities as well, because these come up very, very often. Okay, if you've looked at my prediction videos, you'll see these skills come up all the time. So I did want to devote a fairly small section just to going through these. So our first question here is we need to factorise fully. So that's important, this word fully, because we need to factorise not just the number part, but also the algebraic part as well as here. So in this question here, we have, first of all, 15 and 20. What's the highest common factor of 15 and 20? What's the highest number that goes into both? Well, that's going to be 5. Now we actually look at the other term. So we see it as a y to the power of 4. Remember, that means the same as y times y times y times y. And here we have a y cubed. Y times y times y. How many y's do they have in common here? Well, they both have 3 y's here in common. Therefore, our common factor from an algebra point of view is going to be y cubed. Those are the y's that they share. Now, once we've discovered that highest common factor of the entire expression, then we work backwards. So what do we multiply 5y cubed to get 15y to the power of 4? Well, we need a 3 because 5 times 3 is 15. Y cubed times what gives me y to the power of 4? Let me write it over here. And we've done some work on indices already. And again, we're missing that y to the power of 1. So we put in a y here. We do exactly the same with the second part here. So what do we do to 5 to get to 20? We multiply by 4. There is a u there, so we need to include that. And y cubed is already outside. So our final answer here is just 5y cubed, 3y plus 4u. Often students make mistakes on this question because they're always expecting to factorise into double brackets, but sometimes you do have these single bracket questions as well. Here we have a fairly straightforward equation to solve here. So again, it's just taking our time, making sure we do inverse operations. The first thing I generally do with these questions, if I see a fraction, I want to get rid of it as quickly as possible. So what's the opposite of dividing by 4? Well, timesing by 4 on both sides. Now, by timesing by 4, this cancels, leaving us with 5 minus 8x. This is where we have to be careful on the left-hand side, because 4 times 4 is 16, but don't forget to multiply the minus 3x by 4 as well, which gives us minus 12x. So it's all about just being careful as we go through these equations. At this point, I then have a look at which has the fewest amount of x's here. Well, that's the minus 12x. What's the opposite of minusing 12x? Plusing 12x on both sides. This cancels, giving us 16 here. And then 5 stays as it is for the moment. Minus 8x plus 12x is plus 4x, like so. Once we've got that, then we're going to focus on the numbers. So we want the x on its own. The opposite of adding 5 is minusing 5 on both sides. 16 minus 5 is 11. This cancels, giving us 4x. And we're almost there. We just need to remove that 4. What's the opposite of timesing 4? Dividing 4 on both sides. That then gives us x is equal to 11 over 4. Now, generally speaking, on IGCSE Edexcel, they do like you to write it as a decimal. So in this case, you can do 2.75. Again, if you don't want to do your conversions, you can just use the calculator. That gives you then 2.75. So you can have a look through the mark scheme there and see where you pick up those method marks. Now we're going to have a look at some inequalities. Again, a very important skill, particularly on Edexcel. They do put an odd inequality question in, or as you've seen in earlier parts to this video, they insert inequalities into a quadratic question, for example. So here, n is an integer. Remember that word that's come up, I think, 3 times in this video. A whole number, that's important. And write down all the values of n such that it fits between here. So minus 2 is less than or equal to n, and n is less than 3. That's how you'd read it out loud. And if you need to repeat that, just rewind about 15 seconds. So this one here means less than or equal to. So in this case, n is allowed to be minus 2. And n must be less than 3, so minus 1, 0, 1, 2, but not 3 because n is strictly less than 3. It can't be equal to 3. And the next part, again, very typical in IGCSE, is to represent this on a number line. So the first thing is we've got a less than or equal symbol, which means on our diagram we need to put a filled in circle, like that. And because we're less than or equal to 1, we need an arrow going in this direction. I hope you've got a ruler at home because it makes it much neater. But essentially, you have your dot at 1 and then an arrow to the left. Again, you can see that in the mark scheme there for you as well. Interestingly, this notation is also allowed, but I think most teachers would teach this with a closed circle. And the next part here is expand and simplify. Very common idea here on the IGCSE course. Again, we've got 2 single brackets, so we're just doing the single hook for each of these. So let's go through this carefully. 3x times 2x, that's equal to 6x squared. 3x times 3 is plus 9x. Minus x times 3x is minus 3x squared. Minus x times 5 is minus 5x. So just be careful with those negative numbers. Then we collect up the like terms. So we have a 6x squared minus 3x squared. That's 3x squared. Then we have a 9x minus 5x. That gives us plus 4x. So we pop that down in the space here. And we've seen this phrase in a couple of other parts of the video, making t the subject of this formula. So we want t on its own. This is what it's asking for. Now, the way we tend to do this, first of all, I'm going to flip over the equation. So at minus d is equal to p. And I'm just going to keep chipping away at it and try and get t on its own. Our first step here is this minus d. It's kind of a pain. So what's the opposite of minusing d? Adding d on both sides. So this cancels, leaving us with at. We are making progress. All very good. P plus d, that's equal to p plus d. And then we've got this annoying a. Remember, at next to each other is the same as a times t. So what's the opposite of timesing by a? Well, divide by a on both sides. This cancels. We then get what we want. And then we get p plus d all over a. Just make sure you write that very carefully at the end. So that fraction line goes all the way across. It's not p over a plus d. It's p plus d all over a. So we're just going to write that in the answer box, like so. Right, and you can check the working there as well in the mark scheme. And our final part is a slightly more tricky inequalities question. You'll notice the algebra skills that they test you on, these sort of fundamental algebra skills, generally towards the start of the paper, so they are generally the easier questions. Now with this inequality here, or inequalities I should say here, we're going to kind of do this simultaneously. So what I mean by that is we're going to chip away at this 2x minus 3 until we get x on its own, and we do the same to all sides of our inequality. What do I mean by this? Well, we have a minus 3. What's the opposite of minusing 3? Adding 3 on all parts of the inequality. So what I mean by that is minus 7 plus 3 is minus 4. The minus 3 cancels here. Don't forget we've also got the 5 over here, so 5 plus 3 is equal to 8. And now we've got a times by 2 next to the x, so we're on the opposite of that. Notice the parallels with what we've done in previous parts of this part of the video. And that means we get minus 4 divided by 2 is minus 2. This cancels, which is nice, leaves us with x. And then 8 divided by 2 is equal to 4. I think that's quite a nice, elegant way of doing these kind of questions because you're using the same method that you've seen with equation skills as well. Now, once we've got that solution, it's kind of the irritating thing about this question. If you get this part wrong, then you're likely to miss out on these 2 marks as well. How do we write this down? Well, let's look at the inequality symbols first. This is a less than or equal symbol. So at -2, we need a filled in dot. Whereas here we have a strictly less than symbol. So we need an open dot. And the solution set is anywhere between these 2 points. So we just put a line straight in the middle, like so. And that gives us all 2 marks. Once you understand what's going on here, then you can get an easy 5 marks on this kind of question. So you can see the solution there. So make sure you've gone through that nice and carefully. See where you're actually picking up these method marks. So hopefully you made it to the end of this video. I know it's a very, very big video, but if you want a crash course in all things IGCSE Maths Edexcel, then this is the video for you. However, there are some topics that I have not covered, things like vectors, kinematics, circle theorems. If you want to cover those more tier 2 topics, then check out the video right over here, because this is a playlist of 130 videos at this filming this particular video. So it'll expand, of course. So if you want me to do more specific videos for IGCSE Edexcel, please let me know down in the comments.